Well, good morning, everyone. I want to welcome you to today's latest Wires Technology webinar. With us today, we have Mike Haight, Nathan Stahl, and Luke Chaput from Ampjack. And they're here to talk about their new ExoGrid system, which is used to expand capacity on existing rights of way. And they're going to have a video presentation for us to give an overview of how that new system works. When we get through with the video, we'll have some questions. We'll try and probe a little bit more about this new system. And then we'll open it up to questions for anyone who's watching, anything they would like to find out more about the system or questions they have based on what they've heard or seen. Put them in the question function, which is on the right-hand portion of your screen. If you type it in there, we'll have the question, and then I'll put it out for either Mike or Nathan or Luke to respond to. So with that, Mike, I'm going to turn it over to you. You can give a little bit of an introduction to the video. We'll go ahead and run the video and get started.
Sure. Thanks, Larry. I appreciate it. And thanks, everybody, for joining us today, taking time out on a Friday here to learn more about what Ampjack is providing to the marketplace to help us with gaining more capacity out of existing right-of-ways, which is what you saw on the title for the webinar. Hopefully some of you joined us earlier this year when we did the Ampjack tower raising portion of our tech talk. Since then, we've introduced this new ExoGrid technology that will kind of enhance and take us one step further than what Ampjack tower raising can provide in terms of the amount of capacity we can gain out of our existing right-of-ways. And so, Andrew, if you want, without further ado, let's show that video, and then we'll jump into some of the questions.
In an era marked by exponential population growth and aging infrastructure, the heartbeat of our modern world, the power grid, is straining under the weight of time. As our demand for energy continues to surge, strengthening the grid to support this backbone of the country's economy through investment in modernized and expanded transmission systems will take billions of dollars of new investment, decades of permitting, environmental studies, and new construction. What if instead of building new lines, you could upgrade existing infrastructure for less cost, in less time, significantly reduce permitting and environmental concerns, with little to no new right-of-way development, and having most of the work being done while the existing infrastructure remains in use? Introducing ExoGrid, our patented, simple-to-follow method of converting existing high-voltage transmission lines to multi-circuit configurations. How does it work? It starts with completing ExoGrid's line analysis and design upgrade options to determine and discover the potential full upgrade capacity achievable or to hit a new targeted capacity. From there, we move into phase configuration studies, then foundation and structure analysis and upgrade design, then conductor selection, and finally construction, using the existing ROW and structures as the basis for the entire capacity upgrade. The upgraded tower will require improved structural footings. Upgraded foundation can be integrated into the existing disturbed area, thus removing the requirements for new ROW easements and allowances. Next, using the existing transmission structure and foundation footprint, we affix reinforced structural exoskeleton panels that will be used to support the additional circuits attached above the existing circuits. The existing structure serves as the foundation for rigging and mounting, assisting the installation of structural exoskeletal supports. Once the structure base is installed, additional exoskeleton panels are installed, moving up the tower. Using medium lift helicopters or cranes, the upper section of the EcoGrid upgrade will be lifted and lowered into position, just as when done for new construction projects. Throughout the construction phase, ExoGrid's revolutionary approach ensures minimal interruption to the power supply. While the existing transmission lines may require temporary de-energization during the essential upgrade activities, these short-duration outages are manageably scheduled. This strategic upgrade process guarantees that existing infrastructure continues to operate, maintaining a consistent flow of power. Crucially, at any given moment, the lines can be swiftly re-energized in case of emergencies, ensuring continuity and profitability in infrastructure operations, even amidst ongoing enhancements. ExoGrid can also be used in conjunction with the Ampjack tower raise system to add circuits to the middle of the tower. First, the Ampjack system is installed on the existing tower. The tower is raised to the required height, ensuring safe clearance to the ground and maintaining proper spacing for the upper circuit. Next, a specially designed mid-body extension is added. This extension creates a wider window in the middle of the tower, allowing ample insulation clearance for the new underbuild circuit. Then, the Ampjack system is removed and ExoGrid upgrades are installed to enhance the tower's strength and stability. The lower circuit crossarms are added, followed by the insulators. Stringing blocks are mounted to guide the new conductor into position for the lower circuit. Once the conductor is strung, the blocks are removed and the conductor is clipped into place, completing the electrical connection. The system is finalized and the site is cleaned up for demobilization. The result is a fully upgraded tower with a strengthened structure and an additional circuit seamlessly integrated below the original. Experience a revolution in grid upgrades. With ExoGrid's innovative transmission line upgrade method, witness the ease of construction, significant cost reduction, and a drastically reduced timeline. See the benefits of reductions in permitting, environmental impact, and regulatory hurdles. Embrace a brighter future using sustainable transmission upgrade methods, gaining capacity increase with a seamless installation. It's not just an upgrade, it's a step into a sustainable future. Contact your ExoGrid representative to learn more.
Great. Well, thank you very much. Very, very interesting video. And I got a few questions I wanted to run by you to get us started as a follow-up to the video. I also want to remind folks again that if they have any questions based on either what they've seen or what they hear through this discussion we're going to have, please put the questions in the question function. I'll be happy to pass them along to our trio of experts on this system. So Luke, let me start with you. As Mike mentioned, you guys were in here earlier this year to talk about the system you have for hydraulically raising towers. Can you talk, now that you've got this additional new system put in place, can you talk about how, where the idea for this new technology came from, based on what you've already been doing with respect to hydraulic tower raising?
Absolutely, thank you, and welcome everybody, and thanks for joining us today. Yeah, it's a fun question, and I appreciate it. So, starting on the Ampjack side of things, just quickly, as I think probably a big portion of the group is aware, Ampjack is a fantastic tool and system and method to get additional capacity out of an existing transmission line, but it does have its limitations, right? We're really limited to the thermal operating temperature or the hot sag of the conductor, no matter how much clearance we give it. Sooner or later, we're going to exceed the safe operating limits of that conductor. So, often it's a 20, 30, maybe even a 40% capacity increase with Ampjack. But ultimately, the industry is demanding more out of our existing infrastructure than that, right? From developers wanting to, get in and attach to existing line or transmit, green energy from one location to another, or just having the capacity to run our cities efficiently and safely. We all appreciate and understand that there's going to need to be a significant capacity increase across North America, the world in general. And along with the same theme with Ampjack tower raising, the ExoGrid, we sat back and said, okay, how do we achieve a significant increase in capacity with the same sort of benefits?
Yeah, I couldn't hear a little bit of that.
Oh, I'm sorry. Where did we break off?
About a minute ago, maybe.
Oh,
30
no.
seconds. About 30 seconds, maybe. Go ahead.
All right. So apologize for that. So with the idea in mind that we're trying to achieve a significant amount of capacity increase, using the existing, right away, the existing transmission lines, we sat back and said, okay, what would that take? Well, we would need foundation upgrades, we would need structure upgrades, and then we would need new conductor. But ultimately, having the ability to do that on the same transmission right away would be significant. It should reduce permitting and make construction easier. Ampjack, in the company Ampjack, in the process of tower raising, has started to do all of those ancillary services for our clients for many years: foundation upgrades, capacity upgrades on towers, and the conductor. So we just sat back and said, okay, how do we blend all this together to really achieve a significant increase? And that was sort of how it was born and the process behind achieving this new technology. Hopefully you guys all heard that.
Got it. Yep. No, thank you very much. Sorry to throw you off of the track a little bit there, but no, we got it covered. Thanks. Nathan, let me turn to you for a minute. You're the VP of Engineering for Ampjack, so I'm guessing with that role, you were involved in a lot of the technical aspects associated with Ampjack, and now with this new ExoGrid system. Can you talk a little bit more about how the ExoGrid system works?
Yeah. Thanks, Larry, and likewise, thanks for the invitation here to talk about ExoGrid. So, as the video, the animation kind of lays out the process, and Luke kind of touched on, ExoGrid has been really an evolution of what we've been developing over the last decade with Ampjack, and so, in kind of a concise manner, ExoGrid is a process, a method for upgrading your existing transmission line right away using the backbone of an existing lattice tower or the existing lattice towers to facilitate that upgrade, right? So by utilizing an exoskeleton structural frame, we can add additional circuits above what's already in the right-of-way. Now, those additional circuits, we can use some of the other advanced technologies that are being talked about here, in wires with the wires group, advanced conductors, to really maximize, the upgrade potential. We can incorporate HVDC into that new circuit configuration or conventional high voltage AC phasing. But specifically on the structural aspects of what the ExoGrid is, it's really framing around the existing structure to either fully integrate this added circuit into the structure that we're working on and augmenting, or as a parallel or a independent framework that follows the profile of the existing structure, but ultimately the installation is an independent tower, right? So there are a number of options on the table. A fully integrated design where we're reinforcing and upgrading the existing structure, or framing in a bypass structure essentially.
Great. I wanted to follow up. So if I recall correctly, with the Ampjack system, one of the benefits associated with that was that you can install that, or essentially use that process, and have the line still energized during the process. Is that equally true with the ExoGrid system? Does it work the same way?
Yeah, great question, Larry. So portions of the work, when we're doing pedestal upgrades, foundation upgrades to the structure, segments of the work can be completed energized. But once we do enter into the energized zone, as it were, into the minimum approach distances of the energized circuit, there are staging outage staging requirements. But really the benefit of the ExoGrid is your original circuit remains in place, and so managing outages becomes a very efficient process for the utility. The return to service, emergency return to service of that existing circuit is a very short duration, versus the alternative, often utilities are tearing down, their existing circuits and replacement, right? With the ExoGrid, we're maintaining that existing circuit in place, and it can be returned to service during those short duration outages that may be needed for the installation of the tower top and working in that energized zone.
Great. And then I wanted to also ask you, because you just mentioned it now too, about you talked about the foundation work. Can you talk a little bit more about what kind of foundation work is needed to accommodate this new system, and how would that be different from a new tower?
Yeah. So absolutely, foundation upgrades. That's a fundamental part of the ExoGrid application. The primary difference, or I guess the fundamental difference between an ExoGrid installation versus a new tower construction is that we have an existing foundation in place, in service, and with the process start to finish, we start with a feasibility study, and during that feasibility study, it partially desktop, so we're collecting asset information, we're collecting information on the foundations, we're analyzing and baselining the design based on what the utility already has installed. From feasibility, we'll move on to condition assessment, right? Because that's a very important part of the process. So getting a baseline of that existing foundation that's already in the ground is the early stage of the process. But because we have an existing foundation, when we have residual capacity, that's a topic we often talk about. We're augmenting that capacity with the ExoGrid application. So load sharing is kind of the primary method where we have that backbone structure that we can build off of. So whether it's an existing grillage, a concrete pier, concrete caisson, we have a number of techniques where we can incorporate, additional foundation elements, micro piles, helical piles, grouted displacement piles, concrete encasement and enlargement of shallow depths of the foundation, but ultimately tying those new foundation elements into that existing foundation. Or as an alternative, if during the feasibility and the condition assessment phases, for whatever reason, we're not happy with what's in the ground as an existing structure, there's the load bypass options, right? Where we're going to develop a new foundation around that existing foundation and transfer the load either of the structure that's there plus the exoskeleton to a new foundation. So the options are really very numerous. But it is fundamental to the process is baselining through feasibility and condition assessment what's in the ground, and then developing the optimum technique to enhance the capacity to the requirements.
Great. Mike, let me turn to you for a second. Nathan mentioned about how you can wind up adding some new circuits above the existing transmission lines, but I thought when we were looking at the video, it looked like maybe you could do it also below existing ones. Is that right? And if that's right, how does that process work, or how is it different doing it below versus above?
Sure, thanks. Yeah, up until last night, I'll be honest, that part of the video wasn't even in there. So I'll try not to repeat too much because it does a really good job of kind of illustrating that process. But what we've kind of been talking about with our clients that early on with ExoGrid and some of the opportunities that are coming out of it, yeah, it was originally designed with that circuit to be built above existing ones. But in conversations, we've come to find and had those challenges presented to us where we have utilities saying, well, what if I don't need another 345, 500, 735 circuit above my existing? I can get away with a 130, a 230 kV. How would that work and how would it be different? And so Nathan and his teams from an engineering standpoint came up with that process to be able to put an underbuild rather than necessarily adding a circuit on top. So marrying that with that tower raising, idea, using Ampjack to raise the structure, get your clearances you need, and make the structure capable of accepting an underbuilt circuit that has a lower voltage became a really attractive opportunity for the clients to get that power flow they need, but without having to necessarily go through the process of putting a circuit above, which can lead to easier permitting, easier constructability. And the nice thing, and it kind of goes back to the question you asked before, Larry, if we utilize Ampjack with the ExoGrid, that can potentially be done while it's completely energized. Because we're raising the tower utilizing Ampjack, which we do energized, all day long, and you're working below the existing circuit, now we're stringing the conductor, we're outside that, minimum approach and safe working zone. It allows us to potentially do that upgrade while the entire circuit remains energized on that upper circuit. So from a reliability, from the outage planning, there might still be, some minimal outages for tension mitigation and certain situations where we just can't necessarily do that work while it's still energized. But you're talking a matter of days, couple of weeks, as opposed to, like Nathan said, you knock down the first tower on a line to rebuild the whole thing, and you're out until the day it comes back on. In this situation, now we can remain energized on that upper circuit with minimal outages on it to be able to get that that underbuilt lower circuit utilizing Ampjack and ExoGrid in combination.
Great. So Nathan, let me come back to you. So we talked somewhat about using the system for adding additional circuits, but are there any other applications that go beyond just using the system besides just adding circuits to it?
Yeah, for sure. So, and that's been one of the exciting things about launching, a product like ExoGrid. In the short time since we've introduced, this as a solution, we've already seen an evolution into new and unique applications, and Mike's touched on one of those there, adding the circuit below. Some of the other applications, we're talking with a number of clients about voltage upgrades, right? So you may have an existing 345 kV circuit right away that need additional capacity in that right away, and so looking at the feasibility of taking a 345 kV structure and converting it to a 500 kV structure using the ExoGrid application. Reconfiguration of the existing phasing in your tower, right? To optimize circuit configuration, multi-wire bundling. So may have structures that have single wires and single wire per phase, and we want to add multiple bundles and combine that with advanced conductor, right? So these are all applications that have come up over the last number of months with a number of different clients. So that's an exciting part of the application. And then grid hardening applications, or what we would call upgrading grade of construction, right? So converting a tangent structure to a dead end configuration, or incorporating additional broken wire capacity into an existing tower, right? So just the general strengthening of structures using this application, right, is also something we're looking at, at feasibility stage on some of those at this point, but really good potential for ExoGrid. With kind of parallel to voltage upgrades would be reframing tower tops to increase phase spacing. So it may not be a voltage upgrade that the utility's after, but it may be an enhanced tower top with increased phase spacing. They may be issues with fowl, with birds, with some deficiency of the existing tower top, right? So these are all applications that we're working on. And then to kind of conclude that, it's not just about a line upgrade from station to station necessarily, but it could have an application on some lower scale applications where you may just have a new transmission line right away that's being developed, and you get into a very curtailed or a section of the right of way where there's just no room to add the additional circuit, and routing becomes an issue. So we may be able to introduce some ExoGrid for 2, 3, 10 spans to route a transmission line, and especially with the lower circuit out, lower position application, that may be a tool in the toolbox for the industry. So there's a lot of exciting new evolution and adaptation of the application already.
And
Great.
there's one thing, let me just jump into, Larry, please. One thing that Nathan didn't mention, but it goes to that increasing the loading on the towers. One of the things we're looking at early on too is for extreme weather hardening. So part of that grid hardening and upgrade process, there's a lot of utilities that are looking at this, even when they're not looking at doing new circuits or adding voltage or adding any additional capacity. Yes, all of those are great opportunities, but we're seeing a lot more of the extreme weather, especially in the Southeast, South United States, being able to increase the tower loadings to withstand higher wind loads. So the more extreme weather, the more these big storms and events come in, how do we save and maintain existing right-of-ways to create that more reliable system? That way, while we're building all these other lines, we're not having to worry necessarily about the weather taking out the existing ones, because then we're in some extreme N-1, minus God knows what, when towers can't withstand those weather events. So that has a portion of that grid hardening conversation, even when circuits aren't being added to the towers whatsoever.
So it's an interesting thought, because I was just thinking, so is there the potential for you to, given some of these extreme weather issues that are being experienced, is there the potential to use the Ampjack system to raise the infrastructure, and then ExoGrid sort of on top of that if you need to further strengthen it for some reason? Is that something that might happen, or
Yeah,
people,
absolutely, Larry.
be
Yeah,
looking
so that
possibly
is exactly part of the evolution of what we've been doing with Ampjack. That is an applicable application as well. Yeah.
Okay, interesting. Luke, let me turn to you for a second. So if I understand it, this ExoGrid systems was rolled out relatively recently, I think in August. You've got the ongoing Ampjack system and the work with that. Now you've got ExoGrid. Can you talk a little bit about how Ampjack or the company is prepared in terms of potential need or demand with this new system in conjunction with what you've already got going on with Ampjack as well?
Yeah, thanks, Larry. It's a great question, and appreciate it, and appreciate the awareness of being busy. 100%. So, as often, or as many people in the industry know, we've always held pretty tight, on pretty close Ampjack to our heart, sort of thing, and we've always mostly done, probably 90% of our work has always been done, completely by Ampjack, full EPC style company, engineer, procure, construct. And that's worked well. We've definitely partnered with some great partners over the years, and that has also worked very well. But we've always tried to expand the services for tower raising, internally. ExoGrid is a very different animal. And again, we sat down and said, had this long conversation about how would we be able to maintain, the growth and the the expansion of services and resources, if this catches on. And obviously it's already starting to catch on, and which is very exciting for us. But we decided back, early on, that what we really wanted to do was share this with everybody, right? Whether it's through licensing opportunities or partnerships or joint ventures, whatever it is, we'd really like to see, other engineering firms, other construction groups, other developers, conglomerates of any one of those, opportunities there to really, take the ExoGrid solution and help the industry expand much quicker than it really is able to right now. As we know, trying to develop a new right of way is anywhere from 10 to 15 years these days. we're excited about the idea that ExoGrid might be able to really fast track that. We're not saying that it's solving all of the issues, all the political, all the environmental, but it certainly should be reducing a lot of those significant challenges and helping fast track. And what we want to do is be here to help everybody, whether it's through engineering, assistance, development, training, and then licensing, or a utility who wants to have a developer own a product or the line itself for a period of time, right? All of those things we're excited to join, partner with groups, like I said, through licensing opportunities or just long-term relationships, return on investment, capital investment, development investment, all of those things, right? So we're excited about that. It's a very new product and a very new way for Ampjack to look at doing business, and it's been a lot of fun. It's expanding quick, so we're excited.
Great. Well, I'm actually starting to get some questions coming in here, but I've got one or two more myself. So please keep sending those in, and I'll get to them. I wanted to loop back to you, Mike, and just talk, now that the system has been rolled out for a couple of months or several months now, I guess. What are you starting to see in terms of some of the early opportunities or case studies since you've launched this system?
Sure. So early on, we've seen, again, a lot of changes and morphing of different opportunities and challenges that are coming out of ExoGrid. I know Nathan and his engineering team are working on a few he mentioned with, converting existing towers from a single to a bundled figure configuration, utilizing a advanced conductor on them. So their client in that case is looking at opening the upper window of the tower for the insulation requirements and strengthening the structure in order to go from a simple single phase configuration to a twin bundle. In that case, you're basically going to double your capacity utilizing your existing towers with, quite frankly, minimal changes to the structure versus trying to wreck and rebuild the entire thing. We've also been looking at some of those early cases for raising the towers and utilizing Ampjack to gain the clearance and putting those underbuilds. So there's a couple of those. But one of the big ones that just kind of shook out over the last month is a project we were working on with a developer. They went to a engineering firm, had them do a study on a line. It's a couple 100 miles long. And their early, findings were they had two options. Wreck and rebuild the entire line. It was going to take about 7 to 8 years minimum to do that. And it was going to be about 1.9 or just $990 million, just under $1 billion. Or buy new right away, build a whole new parallel line somewhere in the area, whether they could get it onto that right away or have to reroute the entire thing. That was going to be a 10+ year project and was about 1.1 billion estimated cost. We're still working through the study from an ExoGrid standpoint, but we know we can upgrade those towers, change the voltage, add some additional bundling, and we estimate it's going to be roughly half the price and less than half the time to do it. Again, those are rough numbers because we haven't really gotten all the way into it, but it just kind of goes to show that there is opportunity to save existing structures and existing transmission lines and get those upgrades without having to go to, in this case, what that engineering firm, they didn't know this existed, and their default is wreck and rebuild, build a new one entirely. That's really the only two tricks they had in their bag, where we're now going to be able to offer a significantly better option, both from a cost and a timeline standpoint, that wouldn't have been otherwise, applicable 6 months ago even. So that's some of the early stuff we're working on, and again, the interesting opportunities and challenges keep getting put in front of us, and kudos to Nathan and his engineering team to continually find these unique solutions that, we're working on. Other things we got, we've been working with the Department of Energy quite a bit here early on. They've been, gravitating towards this. Some work with Idaho National Labs to actually do some real world case study and proof of concept on some of our early clients' potential towers to really showcase what this can do in the marketplace. So, things are starting to roll, and hopefully we'll continue to build upon that coming up into the new year here.
Well, Mike, you just took away two of my questions focused on cost savings and timeline issues. But I do want to follow on part of that, because I thought that was interesting. I mean, it just sounds, this is just very rough back of the envelope, but it sounded like 50% less on costs and 50% less on time, roughly from what you were saying. And then on the cost issue, is that just looking only at the construction costs associated with it, or does that include things like the reduced outage times and stuff like that with this type of a system versus a wreck and rebuild?
Sure. So it's interesting. It's not necessarily just the construction. In that case, we're talking the construction, the new conductor that would have had to be put up. I think they were looking at some advanced conductors, which, that could eat up almost half the price of that project just in, conductor pricing. That's just the nature of it. But it really boils down to how the utilities and how the ISOs and some of these groups look at and put a number to those non-outages. We face that even with Ampjack now. There's some utilities that say when we take an outage on a line, it costs us X amount per day on that line, and we associate that with the cost of the project. Whether or not the utility or an ISO or whatever these groups are looking at, whether or not they put a number to it, there is an inherent cost to take an outage. There is a cost to wreck and rebuild a line. And, whether or not, you're actually putting a number to that, we all know there is a cost to do that. We all know there's a cost to go buy, additional transmission capacity when you lose one of your lines because you're rebuilding it. So it opens up the opportunity from a reliability standpoint and a cost saving standpoint from, the non-loss of revenue, if you want to look at it from that aspect, or the non-outage requirements, however you want to use the terminology to do that. There is definitely significant cost savings when we can keep lines energized, even for a portion of a project, rather than taking it out of service for the length of that, construction period. Yeah, Luke.
Yeah, go ahead.
If I could add a little bit to that, thanks, Mike. That was a really good in-depth response. The other side of things, which is a lot trickier to calculate, but I think the whole industry understands the costs associated with it, is right-of-way development, permitting development, delays in construction in general. What's the cost of not building a line for 15 years versus having a line rebuilt or recapacity, with additional capacity in 5 years, right? Those are the sort of the, I don't want to call them soft costs. They're certainly not soft, but they're the complicated ones that it's really hard to put a fixed number on it. But I think we can all agree that it's a significant issue, right? When you cannot get developers who are producing new energy connected to the grid for 15 years, what's the loss in that, right? What's the cost associated to that? And that's what we're really trying to do, is help utilities just get more power flowing in a much quicker response. We're not trying to eliminate the need for building new lines. We all appreciate and understand. We're all from this industry. We know that there's always going to be new lines that need to be built. All we're trying to do, and Nathan said it earlier, that another tool in a toolbox, right? And that's really what we're trying to offer. And this time we're trying to offer to everybody who really wanted to see the industry have a solution or potential multiple solutions that help get us across the finish line here, because we've been struggling for a long time. We've been doing things the same way, and we need to look at the way we approach problem solving in this industry. We need to look at how we overcome with new technologies, and it's been fun to watch in the last 4 or 5 years how there is a lot of advancement in technologies. This is just another one that we're very happy to introduce.
Great. Well, I've got another question here in the question function I want to go through. If anybody has any additional questions, please try and get them in. This is it says raising towers might you might see different wind speeds hitting the conductor, and that can impact positively or negatively. Is that taken into account while evaluating the overall benefit and risk associated with the process?
Simple answer is yes. Maybe expand.
Well, I believe what the question is probably referring to is height adjustments due to wind speed, right? So as your conductor, increases in height, you have a different wind profile. I believe that's how I'm interpreting the question. And so yes, that is part of the analysis process, the detailed design process. In short, and part of the design that's developed.
Okay, great. Well, that closes out the last of the questions that came in and the questions that I wanted to go over. I want to just pause and give you guys an opportunity if you had any closing thoughts or additional things you wanted to add to the overall presentation.
No, appreciate the opportunity. It's always fun to get out in front of, even though we can't see who's out there today, it's always fun to get out and have this conversation. You know how to get a hold of us. We're pretty easy. We're not hiding from anybody. So if you got additional questions, you know, ampjack.ca is pretty easy to find. Mike's always willing to fly over somewhere and answer questions in person. So we appreciate the opportunity and the time.
Great. Well, very interesting new technology and a new addition to the hydraulic Ampjack process you talked about several months ago. So thanks for coming in and talking to us about how this type of technology can be used to get more out of our grid. That's what we're focused on right now. So thank you guys very much, Luke, Mike, Nathan, for coming in and doing the presentation. I want to thank everybody for joining us for this webinar. Stay tuned. This is the last one I think we have for this year, but we will be doing some more in the coming year. So thanks everybody for joining us, and thank you guys at Ampjack.
Take care, everyone.
Thank you, Larry. Yep.
Bye now.